Polynomial division using the grid method. This is a lovely method to use if you find long division tricky. Also really good if you make silly mistakes on your pluses and your minuses. Let's have a look at how it could work for you. Step one is to draw your grid. And in order to do this, you need to determine how many rows and columns you need. So I know I'm dividing a cubic. I'm dividing it by a linear. Now, a linear has two terms. That's going to tell me, okay, I need some two, it's a 2 by something grid that I'm doing. But what is the other grid? So I've got a cubic. I'm dividing that by a linear term. What would the result be? Well, it would be a quadratic. Now, ordinarily, a quadratic has 3 terms, and my linear factor has 2 terms. So this tells me that it needs to be a 2 by 3 grid. Okay, so let's draw that out. What would that look like? So here's my 2 rows. This is going to be for my linear factor. I've got an x and I've got a -3. So those are the 2 components of my linear factor, and each of them are going to go in their own box. Now we've decided that a cubic divided by a linear is a quadratic, so that is 3 terms. So let's see, 1 column for your ax squared stuff, another column for your bx, and then the final column will be for your c. Okay, grid made, let's do our division. And it is really as easy as multiplying, adding your diagonals, and then doing some comparing. So multiplying, and these are the terms I'm going to be multiplying. Okay, so the x and the -3 is going to get multiplied by something to produce the terms within the cubic. So I'm going to work from right to left. Okay, so I know when I multiply the numbers together, that's -3 and whatever number's sitting up there, the answer would be a +45. Then I think to myself, okay, what do I need to multiply -3 by to get that +45? Well, that's got to be a -15. So awesome, that's a -15 in that quadratic that I need to produce. So I've got that bit. Right, now that I've got this, I can do a little bit of multiplying because I've figured out that a -15 lives here. I can multiply that with my x to get me a -15x. Okay, this is where the diagonals comes in, okay? So watch carefully. I know that my x's in my cubic should be -12x. Now looking at my diagonals for the x's, I'm going to colour them in so you can see them. At the moment, I've got -15. I don't want -15, I want -12 x's. So what must live in this box? -15 plus 3x would end up giving me that -12x. Okay, so literally, can you see how we're just comparing coefficients? We were adding diagonals just to get the numbers that we need. Right, now that I have these numbers, I've got that 3x living there, we can do some multiplying. Again, think in your head, -3 times what would give you that 3x? Well, then that has to be a -x. Okay, think about it. -x times -3 gets you that +3x. Okay, awesome. So because we've got that, I've figured another bit out in my quadratic. Okay, so I know I've got a -x in there. Right, let's do some multiplying now to find out our missing bit. So -x times x, what does that give me? -x squared. Awesome. Now I'm going to do a little bit of comparing and a little bit looking at diagonals. I want my x squareds to be -7 of them. And at the moment, I've only got -1. But we need -7x squared. So what must live in this box? What must I add to that? That must be a -6x squared. Okay, so it's comparing. You can see comparing, adding. Awesome. Now that I've got that, I can do a bit of multiplying to help me figure out this last final empty number over here. What times minus 3 would end up giving me minus 6x squared. Well, that must be a positive 2x squared. So check, 2x squared times minus 3 is minus 6x squared. Awesome. Let's fill in the last box. And if I've done everything right, then this last term should match up with the first term of your cubic. And does it? Yes, it does. Happy days. So f of x equals x minus 3, 2x squared minus x minus 15, which is awesome. But we haven't actually answered the question, because what do we actually need to do? We need to fully factorize it. So x minus 3 is done. Can't factorize that anymore. However, sometimes you are able to factorize the quadratic term. Now I'm going a bit old school. I'm doing it by hand. You don't need to do that. You have your calculator, use it. Just find the roots and they will tell you what the roots are. If they're imaginary roots, it means you cannot factorize that quadratic. If they're real roots, you can use that to figure out the linear factors. So old school means I'm multiplying to get minus 30. I'm adding to get minus 1. So let's split up the middle term. What do I get with that one? Two numbers I multiply to get minus 30, add to get minus 1. I'm looking at minus 6x, and I'm looking at a positive 5. So let's now do some mini factorizing. Factorize the first two terms. What do we get? 2x and then x minus 3. Last two terms, factorize out the 5 to leave me with the same bracket. Awesome. That means I can finish off my f of x, and I can write that as 3 factors. I know one of them's x minus 3. Looking at the quadratic, one of the brackets will be 2x plus 5. And the final bracket will be x minus 3. And that's it. Done. I've fully factorized it. Here you go. You guys can have a go at this one. I have the answers coming up, so you can just pause the video, have a go, and then play to get your answers, which are on the next slide. Here are your answers. Compare and see. This quadratic cannot be factorized any further, so I have fully factorized it. Cannot do anything more with that. So we stop. Thanks for listening. Hope you found it useful.